Okay, moving on to the next ones. Again, you want to write the functions identifying slope and y-intercept. So this first piece over here, slope, y-intercept. Your slope is going to be from left to right, it's going down, notice. Okay, so here it's going to be up 4 to the left 3. So that's 4 over negative 3 or negative 4/3. Your y-intercept is at 0. On this side, same thing, slope, y-intercept. Your slope is again the same slope because you're going to go up 4 to the left 3, so that's still negative 4/3. Your y-intercept, though, however, this time is now at 4. Okay? Yes, hold on. So now I'm going to write the equations. My first equation over here is going to be negative 4/3 x plus 0, or I can just write negative 4/3 x. And then for my second one, it's going to be negative 4/3 x plus 4. Now I'm going to write my intervals. Now notice this one keeps going to the left, right? One of my boundary lines is going to be right at 0 again. Okay, one of them is going to be right here. So that's still, in this case, if x is less than or equal to 0. So for this piece of the equation, it starts here and it keeps going down. So that's everything less than or equal to 0. Now this one is going to be a little bit more tricky because notice this one has a stopping and a starting point. So it's not just going on to infinity in both directions. So therefore, what I have to do is I have to take that into account. So I say if it starts at 0, not including it, so I'm just going to say is less than, but is less than or equal to the stopping point, which is at 3. So it only goes from the interval of 0 to 3, and then it stops. It doesn't keep going on to infinity. Next graph, I have 3 pieces, therefore I'm going to have 3 equations. So I need to identify slope and y-intercept for each piece. So for this first one, my slope is going to be, it looks like it's up 2, or up 1 over 1. Let's see, up 2 over 1, 2, 3. Well, I guess that's a little bit more accurate. It's kind of hard the way it's drawn, but really I would say that this is up 2 to the left 3, so that's negative 2/3. Now, notice that this equation does not have a y-intercept, so I need to continue that slope to see where it hits the y-axis. So again, I'm going to continue that, go down 2 over 1, 2, 3, and notice it's going to cross through the y-axis right below 0. So right below 0 is probably going to be at about 1/3. It's not quite half, it's not 0, so let's estimate it to be about 1/3. So my y-intercept is going to be at about negative 1/3. Now probably for your quiz, it's not going to be that difficult to tell what the y-intercept is. It's going to either probably be a half or a whole number. Okay? But that was just so that I could find the y-intercept of that piece. It's not really part of the function, remember that. This piece here has a slope of 0, because it's a horizontal line, and it passes through the y-axis at negative 3. And then finally the last piece, again, this is just going to be, well, it looks like it's up 1 over 1, but that's not consistent through the whole graph. It looks like it's more up 3 over 4. I think that's just really close. So I would probably give you credit if it weren't exact and it was kind of iffy. Okay, so your slope of this line, we're going to call it 3/4, and the y-intercept you actually have to, oops, I didn't mean to do y equals, I meant b equals. Your y-intercept, you're going to have to continue it because notice it doesn't hit the y-axis. So you're going to have to go down 3, and to the right 1, 2, 3, 4, to the left. So notice that it looks like it hits the y-axis right at 0. So your y-intercept is 0. So now I'm going to write my function. I'm going to have one piece right over here of negative 2/3 x minus 1/3, and that's if, we'll fill that in a second. Our next function is going to be 0x minus 3, or just negative 3. and if, we'll fill that in just a second. And then my last piece is going to be 3/4 x plus 0, or just 3/4 x. And that's if. Okay, so let's see what our boundaries are in this case. Let's draw our boundary lines in. So we have one boundary line here, and we have another boundary line here. So the first one goes from, let's see, what x value is that? 2, right? -2. So it goes from -2 to the left. So that's everything less than -2 or equal to. The second piece is an interval because it starts and stops. It doesn't go on to infinity. So it starts at -2. I don't include that, so it's just less than x. And then it goes up to +2, but I don't include -2 or +2 because I have open circles. And then finally, my last one, 3/4 x, that one's going to start at 2, including 2, and it's going to go all the way up to infinity. So that's just x is greater than or equal to 2. Board here. So for this first line, you go up 1, 2, 3, 4, 5 over 1. So your slope of there is 5 over 1, which is just 5. Now notice you don't have a y-intercept, so you have to continue. Up 1, 2, 3, 4, 5 over 1, and there's where it's going to hit the y-axis. So that value is 1, 2, 3, 4, 5, 6. So B is 6. For the next one, notice that this hits the y-axis right below the value of 1. So right below the value of 1, that could be like 7/8, or it could be 3/4. Okay, I'm not going to have you calculate that exact. I'm okay with you estimating that for now. So again, slope and y-intercept. So your y-intercept here is going to be at about, we'll call it 3/4. And again, that's just an estimate of about where it hits. And then you're going to go over 1, 2, 3, 4, 5, 6, down 1, 2. So that's down 2 is a negative. So 6 over -2. Can I simplify that? Can I simplify 6 over -2? Yes, I can simplify it to -1/3. So that's my slope and y-intercept. So now I need to do my boundary lines and write my functions. So boundary lines, I have several of them. I have one here, I have one here, and I have one here. Notice that none of these go to infinity. So I'm going to have intervals for both pieces. So for my first piece, it's going to be 5x plus 6 if the x values it's between are -2 and -1. So I'm going to say -2 is less than or equal to x is less than or equal to -1. So that's my interval that this first piece is in, from here to here. Then my second piece is going to be -1/3 x plus 3/4, and that's if I'm going to start at -1, and I'm going to go all the way over, again, my interval, to 1, 2, 3, 4, 5, 6. Last one is a step function. These are all horizontal lines, so you really just need to look and see where they go through the y-axis. So this first piece goes through the y-axis at 2, so you're just going to write a 2. Your second one goes through the y-axis at -1, so you're just going to write a -1. And the third one goes through the y-axis at, let's see, that's 1, 2, -3. And now you're going to write the intervals. So again, draw your boundary lines in. There's a boundary line here and a boundary line here. So this first one starts at, looks like negative, what's the y-axis, -2, and goes down. So it's everything less. So you're going to say x is less than -2 because notice you have an open circle there. The next one starts at -2, you include it, and since it has an ending point, it's going to be an interval, starts at -2 and goes to +1. And then the last one is everything greater than or equal to +1 because it starts here and goes to the right.